Welcome everyone. Today's session is going to be on the topic Docker and containers. I hope my voice is clear. Wait. Yeah, I think so. Just a quick check in the chat. Awesome. So Docker is not something which everyone uses in their project. Most of you, if you have done some internship or you have worked on some full stack open source project, you might have come across the term Docker. But other than that, mostly we don't use that. So it's not in the beginner level, it's kind of like in the intermediate level. But today's session we are going to take a very I would say a beginner friendly approach to Docker, a very intuitive approach, try to understand how it works, what are the reason Docker came up, and after that we will have a hands-on lab where we will try out some of the very common and most commonly used Docker commands. And finally, we will Dockerize an entire Express application. So, and for that hands-on lab, you will need to have an account in Docker Hub. So make sure you create that. It's going to take a couple of seconds. I think you have to also verify your through your email ID, but it's not going to take long. So just create that if you're not ready with it, and that's all. So just sit back, relax, and interact, and hopefully you will have fun and you will get to learn a lot. Brief about me. I'm Arnab Sen. I'm currently the co-lead of GDSC IIEST. And if you want to contact me, you can. There is a link in the slide. You can see arnabsen.bio.link. It has all my social media handles. You can ping me there as anytime. Um, so the first thing that might come to your mind, like why do we even need Docker? Like what was even the purpose that Docker came up? And to explain that, I will take two scenarios. So the first scenario is like this. Let's say there is this organization, or let's say it's you, and you're creating an application. And in that application, you're using, sorry, something like Node for the backend. For the database purpose, you're using, let's say, PostgreSQL. And you have some messaging system or some caching mechanism. For that, you're using Redis. And then there is some third-party API service which is deployed on, which is using Flask. Okay, so this is a highly exaggerated example that I'm giving, but just to give you an idea of the complexity we are dealing with. So this is the application, and now if you want to work on that on an application like this, you need to set it up in an environment, right? So you need to find one environment, and the thing is that each of these framework has their own dependencies, has their own libraries, files which these framework need to be able to run properly. Not just different framework, even different version of the same framework has different dependencies. So like if you run Node 16 in a very old Windows machine, it won't even run. So that's the issue. So if you want to get an environment where you can work with all of these frameworks, you have to find a sweet spot, like that single, place which will satisfy all the requirements of each of these entities. And the thing becomes much more difficult because as we add on more stuff, more entities, more frameworks to our application, finding that sweet spot becomes more and more difficult. This is something called the dependency hell. To give a much real life example, let's say it's a birthday party, it's a birthday and you're giving a party, and there's a group of 20 friends you have, and what you want to do is you want to go to one restaurant which will satisfy everyone's requirements, and it's going to be extremely difficult because every one of your friends will be like have their own opinion. So to just find one specific restaurant is going to be difficult. Similarly, and you can let's say you are an intern to an organization which is having having an application this big, or maybe you are a open source developer and you want to contribute to a project which has this big of an application. What do you have to do? First, maybe remove your current operating system and install the operating system that is needed to be able to develop that application locally, and then install each one of the frameworks one by one, and then manually configure each one of them. So it's a tedious task, right? And that brings us to the second scenario, like how will you set it up in a local dev environment and deploy it? So it is taking a lot of time to even configure the environment, and at the same time it cannot be automated very easily. Let's say you're a DevOps engineer and you want to put this application in your test server, in a production server, and in a development server. So you have to repeat the same task again and again for every time you want to deploy, and it cannot be automated very easily at all. And actually people used to do that 5-6 years ago. At the same time it's not very portable. Like let's say you want your friend to have this setup, this application set up in the local environment. You would have to give them a like a step-by-step procedure, like first install this operating system or create a virtual machine that has this operating system, then install node, this specific version, then install PostgreSQL, Redis, and so on, and then configure node. And that's going to be a huge tedious process, and it's very, very inefficient. As a team lead, you don't want your employees or your developers to spend time trying to deploy, and less you want them to spend more time on the logic and not on the deployment part. So this is the issue that we're facing with. And also at the same time, let's say you're done with the project, and once you're done you have a huge mess, and will take a lot of time to even clean up that mess. There are actually many more issues that you will come across, like you cannot run two different versions of the same frameworks simultaneously, which many organization actually does. So these are the difficulties that came up, and that's why developers from all around the world came up with a solution, which is something called encapsulation. You might have heard this term in object-oriented programming. What do we do in this concept is that we kind of like imagine each single capsules, and each capsule has its own framework. Like it's kind of like an ecosystem. One capsule for Node, one for Postgres, one for Redis, and one for Flask. And that capsule or that ecosystem has all the files, all the dependencies, and all the libraries that Node needs, that only Node needs. So basically that box is going to satisfy the requirements of just Node, and not just Node, the specific version of Node. Same for PostgreSQL, Redis, and Flask, and all the other entities in your application. What this is going to do is just, yeah. So also, it should also give you some sort of isolation. That is, if you're running some process in Node, it shouldn't interfere with another process that's running in, let's say, your database or in your Flask application. There shouldn't be any deadlock situation, like Node is requiring a dependency which also even Flask is requiring. So there won't be any kind of like dependency hell anymore. Now all the requirements of each entities is satisfied by their own capsule, that own, I would say, container, you can think of it. And this actually solves the first problem. Now we don't have to find that one sweet spot, because we just need to look for that specific operating system which is good for a node, one of that operating system which is good for Postgres, and so on. And we can bring them in their own capsule and we'll be good to go. And what about portability? The issue of portability? The thing is that configuration that you did previously of that box-like structure, you can get a blueprint of that configuration. And how is that going to help you? Just like well, we have some buildings and skyscrapers. They have a blueprint which has all the details of that house or the skyscraper. Similarly, our blueprint will also have every single detail, every single data and metadata of that configuration. And with just one command, you can get that exact, this exact configuration, that exact setup of application using that blueprint. Now, if you want to give it to your friend, what you can just do is you can just hand him or her the blueprint, and then just ask the person to just run that command. That's it. They just need to have the the containerized engine like Docker installed, but after that they just have to run that one single command and they're good to go. So these are the two reasons why mainly Docker came up with. So I hope this is clear so far. But then let's dig into what are containers specifically. By the way, this is just a small slide deck of like I think 15 to 17 slides. After that, we'll move on to the hands-on lab. I just want to clear off some fundamental concepts before moving on to the to the hands-on lab. Yeah. And if you have any questions, please put it in the Q&A. I think I've opened the Q&A as well. Yeah, it's open. So you can just put the questions over there. I will address those in between, obviously. So container is a way to package an application with all its dependencies and configuration. So you can take a look at this image over here. So you have Node, you have all its dependencies and all its libraries. And what you are doing is you're just taking all of them, putting it in a box and putting in a container and containerizing that. That's it. And all the dependencies and libraries will be there inside the container, separated and isolated from the, from the outside, from the host you can think of. And what are the advantages of having containers? First thing, it makes the package portable. You can easily take that package from one place to another and you can easily share that. The second thing is the container shares the same OS kernel you are using. Most of you might know what kernel is, but still, like, kernel is you can think of it's a layer on top of operating system which manages the application, the resources and everything. Okay. So what containers does is they don't have their own OS kernel. They will share the kernel that you're using. So if you're on Linux, that means the container that will run on your machine will be using the Linux kernel. If you're on Windows 10, Windows 10 now ships with both Windows and Linux kernel. So you can use both the kernels there as well. And the third thing, you don't have to worry about the operating system anymore. Like you just need to have the container software, for example, Docker installed, and it will simulate that environment for you. So this makes development much easier. This so like now it doesn't matter which operating system you're using, as long as you have the same operating system kernel, you're good to go, and you need to have that container software. So these are the major advantages of having this concept of containers. And this is a very common question, and I remember someone asked this question last session, that then what's the difference between containers and virtual machines? Now I understand the confusion might be that both containers and virtual machines gives us certain level of virtualization and isolation, right? Just like using virtual machines, you can have a Kali Linux operating system running at the same time. You can have an Ubuntu running or something else running parallelly, and they're separate from one another. They're running in isolation, so it kind of gives us the same vibe as containers. But there's a very big difference if you look at the layer in which they're created. So virtual machine has this very important layer called hypervisor layer. And it's just on top of your infrastructure, the hardware resources you have. The main task of the hypervisor is to allocate resources and memory and processes among the operating system which you want to virtualize. An example of hypervisor is like VMware, VirtualBox. All of these are cross-platform. If you're on Windows, you have another called Hyper-V. There are different versions of hypervisor as well. There is hypervisor 1, 2. We're not going to go into that. But the concept is that, and yeah, if you remember, if you have set up a virtual machine in your laptop, you will notice that while setting it up, you have to specify the the amount of memory you want to give, the number of processes you want to allocate. That's what the hypervisor is doing. One more important aspect is that in virtual machine, you need to download the entire operating system. That ISO file, like 3-4 GBs of that ISO file you have to download. So it needs to have the full-blown operating system. But on the contrary, in case of container, we don't have hypervisor. We have something called container engine, which is on top of the operating system layer. So you can think of like the Docker that you're installing, that will be on top of the operating system layer. And what the container engine does is it will just isolate the processes and like kind of like virtualize each of the processes running. So like if let's say application 1 is running process A and process B, and application 2 is running process C and D, it's going to make them in separate something called namespaces, or you can imagine it like separate containers. That is what the container engine is doing. And since with the help of containers, you're using the host kernel, that is saving you a lot of memory. As a result, while dealing with containers, the container size is very less. You will see the container size of Ubuntu is around like 72 MB. We will try that out later in hands-on, but that's it. Like this is a huge difference. And but I want to specify this one thing, that it's not like containers versus virtual machine. Both of them have their own use cases. Containers are mainly used for DevOps purpose and development, and it will because of the reasons I said earlier. And virtual machines are mainly for virtualizing an entire full-blown operating system. So those are different, but yeah, you should remember there's a difference between them, and at what point the difference lies. I hope it's clear so far. I just want to stop over here and ask if I have to slow down, or just is the pace correct or anything like that. Can a container run without operating system provided kernel is installed? No, it cannot. I mean, you need to have the container engine, and for the container engine to be installed, you need to have an operating system. So the if you look at the image once again, the container engine is on top of the operating system. It uses the kernel, but you need to have the container engine installed, right? So I hope that answers your question. Okay, so yeah, so moving on, let's look at specific to Docker. Docker is one such tool that helps us, package our software into containers. There are other tools as well, but Docker is widely used. That's why it's similar to like that of Xerox. Like we don't say photocopy enable, we say Xerox. Similarly, we don't say containerizing our application, we directly say Dockerizing our application, because it's so popular and so widely used. It is a large community, and it has lots of tools and resources available. And even today, we will be using Docker. And before moving on to the Docker, the binary, and just getting our hands dirty, there are three things you should know about Docker. There are three important components, I would say. The first is the Docker file. Docker file is like the blueprint. Remember the blueprint that I said, I think in slide 2. So Docker file is actually the blueprint or the DNA. It's kind of like a recipe, and it gives us the exact instruction that is needed to build an image, to build an exact image. Now, what is an image? Docker image is like the snapshot of the entire application or the software. It has all the details of the application, like which what are the dependencies it needs, what are the process that is going to run when it starts up, and all those information and data and metadata is stored in the Docker image. But understand that Docker image is not the running instance. If you run a container, that running instance of a Docker image is something called the Docker containers. So using the Docker image, you can run multiple instances of the Docker containers. Now understand this. There is Docker file. It's clear. Docker file is like a blueprint. It's like a DNA, and it has all the important steps that I need to create an image. But when I started out, I found difficulty differentiating between container and image. So it will get more clear as we do the lab. But for the time being, you can just think of it like, let's say you have some MP3 file in your disk, right? Uh, Having that file in the disk is not equivalent to listening to the song. Only when you run the MP3 file through a music player, at that point you can hear the music and hear the song, right? Similar, Docker image is just in the disk. It's like the data and the metadata and everything of the running instance. When you run that image, and when you spawn a container out of that, when it's a running instance, at that point you call that a Docker container. uh, if it's still not clear, just hold on. When we move on to the hands-on lab, and when we will be trying out the command, I hope it will get clear much better. With that being said, we are done with the first part. Now we'll be moving on to the hands-on session. So everyone, I would just request you to go to this link. I'm going to put the link in the chat. So go to the link. I'm going to instead share my screen. Just hold on. Chrome tab. Yeah. So let me pin this link over here, and you will see a login option over here, I guess. Click on that, and then there will be a Docker, and then you have to log in with your Docker ID and the password, or the Docker username and password, whatever it is. If you are able to log in and you can see a start option like this, just put it in the chat like, yeah, yes, it's working. Or just click on start. Let's click on start. It will take some time to allocate a session for you. So just let me know if you can see a screen like this. Yeah, it's okay, man. Yeah. Uh, Obiru has a smart idea. Yeah. We just, and then click on add new instance. It's going to create an instance for us, and this instance will already have Docker installed. And the way you can do check is that you press Docker minus V. So do Docker minus V. This is the command. It will give you the version of the Docker. Hopefully you see something like Docker version 20.10.0. Most of you will have that version only. Let me make it full screen. To make it full screen, you have to click on Alt and Enter. And if you want to zoom in, it's Control and plus. Is this font okay, or should I zoom in even more? Just let me know if you can see the messages and everything. Like, hello. Is the font clear? More zoom, okay. I'm running out of space. Actually, it's problem with Baby. Baby doesn't, for some reason, Baby doesn't show the screen properly. Hello. I think I have maxed out. There is no option now. Awesome. Don't worry. I will paste the all the code and everything that I will be saying. I will just paste it over here in the chat as well. So is everyone at this point with us? Just do Docker minus V, DOCKER minus V, and it should something like that. If you want to clear your screen, you can press Control and L, by the way, to just clear the terminal screen. I'll just drink some water. If anyone is facing issue, let me know, by the way. I want every one of us to like follow together and go together. Okay, so what I like, whenever I come across a command or a binary or an executable, the first thing that I prefer doing is going to the help. So let's do that first. So if you go to Docker dash dash help, Docker space dash dash hyphen hyphen help, it will give you a kind of like a menu, and it will give you all the options that are available to us. And I would say whenever you're working with commands, use the help more than you use Google, because what happens is that when I'm trying to when I go to help and I check out, I also read the other the commands that are available, so it kind of like I passively learn new commands as well. So under management commands, you will see something like container. Then you will see another thing called image. Like, we know these terms, and it's under management command. That means if you use Docker container, then it will give you other options to manage containers. And then if you do Docker image, and then it will give you other options to manage images, right? So like if you do Docker container and then dash dash help, you can see it gives you manage containers and more commands to manage the containers, basically. Got it? I will highly suggest you to follow along, by the way. So, and we will be using this dash dash help very much in today's session. We'll try not to Google less and more use the help. So whenever we learn a new language, what do? We first print hello world, right? And there's a Docker version of doing the same. So first, let's see the command, and then I will explain what's going on under the hood. So the command is Docker container run then hello hyphen world. This is the exact command. Docker container run then hello hyphen world. Press enter. Something is going to happen. You will see an output similar to this one. Here is the command I pasted in the chat. So if you see a similar output, just react with thumbs up to that that message that I just sent. Great. Yeah. So awesome. So let's go line by line and see what's happening. The first line it says is unable to find image hello world latest locally. So what this command actually does is Docker container run, then the image name we specify is going to run and container from the image. So when I gave this command, it was unable to find the image hello world latest locally. Now what does this latest refer to? Generally, all images of in Docker can have certain tags or versions. You can think of it. Since I didn't specify any version, it by default took latest. So, and the first thing that it did was it tried to find this image locally in my machine. I mean, in this terminal, and this is a new terminal. It doesn't have any image at all. So it wasn't able to find that. So what it did, it said pulling from library hello world, which is kind of like there is this one library called Docker Hub where you all created an account, and it is kind of like a repository but for images, like kind of like GitHub but for images. So it is pulling hello world from that library. The pull was complete. This is just like a SHA-256 of the image, just an identifier. And then you have a status which says downloaded newer image for hello world latest. That's it. Up till now, whatever this 5 lines is generated by the Docker container run. The next line from hello from Docker to the end is generated by the container itself. This is like the hello world message from Docker, and this message actually shows explains the step. So the first thing that happened was the Docker client contacted the Docker daemon. Basically, this Docker which we're using is a client, and we have the container engine running in the on top of the operating system. So when I gave it the command container run hello world, it passed that message to the container engine. The container engine or the Docker daemon pulled the hello world image from the Docker hub. Then it created a new container from that image, and it ran an executable. It is that executable which has actually printed this message. Like we do printf. Similarly, there is this one command called echo. Most of you may know of that. So there is this one echo command which prints this exact message, and that exact message is then shown to our terminal. This is what is happening under the hood when we say Docker container run hello world. Is this clear? Is everyone able to understand what's going on right now? Any doubt, you can put it. I hope it's clear. Okay, I'm assuming it's clear. Do one thing, run the command once again. You will see some difference. Can anyone say what is the difference from this one and the previous one? Thanks, Avirup. Exactly, correct. Upman, you got it correct. Now, previously we already pulled the image, so it's there locally. So this time when I said Docker container run hello world, it found the image locally. All it did was just start the container from the image that we have locally, right? Now, I have one question for you, that how do I know what images are there locally in my machine? And I want you to find the answer to that by just using the Docker help, not anything else. Try to do that. Use the Docker image help and see if you can find the specific command which will give me a list of all the images that is there in my machine. Let's see. How to do that? Correct. Iman got it correct. So it's Docker ls. So let's try that as well. So Docker image does help. So I want to see all the image. So ideally it's going to be under the image command. So let's do Docker image does help. There is this one command called list images. If you're still not sure, you can do Docker image ls dash help, and that will also give you further information, which will like list images, Docker image ls, and there are further tags that you can give. So let's do Docker image ls, press enter, and there you can see we have one image, hello world. It is tagged latest. It's an image ID which is unique to every image, and it has a size which is very small. It's like around kbs. That's it, right? So this is how you can find all the images. There's also another command which I prefer using, which is Docker images. So you can do Docker images and enter, and will give you the same output as well. Now, let's try to look into what an image has, right? So if you move back to Docker image dash help, there's this one command called inspect. What it says is displays detailed information on one or more images. Let's try to inspect our hello world and see what a Docker image actually contains. So let's do Docker image inspect hello. You can press HEL and then just do tab. It will auto complete that. And there you go. It will get a bunch of information. It's in JSON formatted structure. So most of these are not very interesting. Like it has the ID, repo tag. Then it's just it doesn't have any parent. But later on we will see that when we will Dockerize our application, we will see we're going to have a parent image as well. Over here you can see the Docker version you're using. It has some environment setup. So basically all the configuration that we needed for that hello world container to run, it's there in the image. I hope now it's getting clearer the difference between a container and an image. Image is just in the disk. It's just a bunch of information in the disk. But when you do Docker container run and then specify the image, it generates a container, a running instance of that image. And this is a command that ran when it started, which is /hello. And here you get the size, the operating system that was used, some other data stuff and everything. Okay. And now that we have run I think twice the same image, I want to get the list of all the containers that are running. For that, there is this one command, and this command is most widely used. Just like we as developer always keep using the ls command. Similarly, when you will be working with Docker, you will be using this command called Docker ps. What it does, it will list out all the containers that you have, right? Let me put it in the chat. Docker ps. It's not just Docker ps. Docker has a lot of aliases for the same command. You can even do Docker container. Sorry, I think ls, that will also work. But it's not showing anything, right? Can anyone just say what's the reason it's not showing anything? It's showing empty. What can be the reason? It's a very simple reason, to be honest. Like, what can be it? Yes, Suham, tag is unique for all. No, sorry, not tag is not unique for all. Tag is like, let's say you're building your own image. Let's say you're building your own hello world image. Then what you will prefer is you will have, let's say the first version will be tagged 1.0.0, second version will be tagged 2.0.0, and so on. Tag latest automatically takes the latest tag which is there. So the tag is unique to one image, but it's not unique globally. It's auto closed. Exactly, correct. It's a very important thing which you should understand is that Docker container will be running as long as there is a process going on. If there is no process running, there is no point of keeping a container idle, right? So in hello world, it was just had to print, the only process that was running was print that big statement, that hello from Docker and all that stuff. Once it was done, it went away. So how do I see all the commands, all the containers that I previously ran and are now exited? Well, let's just do help and see if help has the solution. Well, the very first thing we see is tag A or dash dash all, and it says show all the containers. Default just shows the running ones. So let's do docker container ls dash dash all or dash A. Let's do dash A, it's smaller. Now we can see, sorry, it's weirdly formatted in my situation because I've zoomed in a lot, but you will see two containers because, but the image that was used was the same because we used the same image to run the container. One was created 6 minutes ago, the other one was created 9 minutes ago. If you don't specify a name to the container, it by default gives a weird name like Charming Franklin, something like that. You can either use this name or you can use the ID. These are unique locally in your machine. These will be unique. I hope you're getting the output to the Docker container ls-a. Most of the time, you won't be using this big command. You will rather use Docker ps-a. It's smaller, right? So the command is Docker ps-a. Ps command gives the current running process, so I suppose Docker is not running. Docker is, I won't say Docker is not running. I would say there is no container running. Okay, so there's no container running at this moment, hence it's not showing. Docker is a different thing. Containers are different, right? Docker is the tool that we're using. I hope it's clear, Jatin. And again, just keep, keep reacting with thumbs up to let me know that you're done with that step at that point. Yeah, it just helps me. Awesome. It's great. Like, wow. So cool. But this time, let's take it up a notch. We want to write our own hello world image, and let's do it with a different operating system. We'll do a different image. Let's take Ubuntu. Like most of us have used Ubuntu, and we will. Our target is going to be a hello world, but we will be using Ubuntu image, not this predefined hello world image that was already there in the Docker hub. So the first thing we will need to do is let's pull the image of Ubuntu locally, right? You can directly run the container run command. If it doesn't find the image, it will automatically pull. But let's try out different commands today, right? So let's do Docker image. We're trying to pull an image. So Docker image pull Ubuntu. And you can see that the commands are very intuitive, right? I see a lot of beginners faces difficulty, like I don't remember the commands. Keep using that commands. It will get you will eventually get a hint what the command might be. And otherwise, help is always there. Else, Google, right? So let's do Docker image pull Ubuntu and let's press an enter. It's going to pull the Ubuntu image and it's going to be done. The entire Ubuntu image is just pulled. It's just in your machine locally. So how will I check? Remember the command, I hope. Docker images, right? So let's do that. Now I have an Ubuntu image. It's tagged latest and it was size just 72.8 MB. That's it. So the command is Docker image pull Ubuntu. This is the command. Oh, okay. Thanks, Ubuntu. I'm just going to delete mine. Message. Let's just, yeah. What is Ubuntu image? Very good question. So, like, so image is, as I said, image is nothing but a snapshot, right? You can always have music which has nothing inside it, right? Also, why are we looking into that? We'll use a Docker inspect command to see what's there in Ubuntu, right? So let's do that. Docker image inspect Ubuntu. And let's see what's there. You will see nothing is there. It's just empty and has all the dependencies and all the libraries that an operating system would need. That's it. So this is the the ID. This is the repo tag. It doesn't have any parent because Ubuntu in itself is a it's kind of like if you think of a sandwich, it's the bread of the sandwich. It's the base layer, right? Ubuntu itself is a base layer. It's an operating system layer. and all it has, it just has a path, and it runs bash. That's it. So if you run a container from an Ubuntu image, it will give you just a bash prompt. That's it, nothing else. And but it will have all the stuff that you will normally see in an Ubuntu machine. Okay, so that's the thing. And while we will doing it, I think we'll get a much more clear idea about what's in this Ubuntu image and what we will have when we run a container from that Ubuntu image, right? So if you want to create a hello world uh, through this Ubuntu, we can. There is one, as I said, there is one command called echo. I'm really sorry. Okay, so echo hello world. You press enter. What it does is just prints hello world, right? So we will build a container. We will restart a container using the Ubuntu image that will run this echo hello world command. Okay, so let's do that. Docker container. My God, what's wrong with my spelling? Docker container run Ubuntu. It will take the latest and then specify the specific command like echo hello world. Press enter and you see hello world. This is like our own version of hello world. Did everyone get the hello world output? So here is the command. Try it out and see if you're getting the hello world output or not. Cool. Now I have one question, a trivia for you. Okay, it's not related to Docker, but how do you know this echo hello world actually happened inside the Ubuntu container and not in my own machine? Like right now here I did echo hello world and it printed hello world, and here also it just exactly printed hello world, right? How do I differentiate like whether it actually printed, whether this command actually ran inside the machine? Any clue? Any guess? Just try out different command, replace echo hello world with different command and see if you see any difference. Sudo apt update. Like sure. Yeah, that's good. Docker ps minus a. Okay, yes, Neeraj, that's correct. Like if you do docker ps minus a, it's going to show me that it ran. Yeah, it says echo hello world, but are you sure that it actually ran inside the container? Well, obviously it ran inside the container. A very quick way to check is you can try a bunch of commands. Like if you see ls over here right now, you will see nothing because there is nothing in my machine at this point. But if you just pass the, sorry, I don't know why the up arrow key is not working. So docker container run Ubuntu, and then you do Ubuntu, and then you do ls. It will show me all the files that are there in your by default in a home. A home in, if you go to any Debian based distro, you will see all these files in the home. You can do, there are any other commands as well. There is one command, you can actually see the operating system release file. So if you do cat /etc/os release, locally it shows me Alpine Linux and the other information about the Alpine Linux. So it's actually running Alpine Linux. Alpine Linux is a very lightweight version of Linux. And if I pass the same command to this, thing, OS, to this container, it's going to give me Ubuntu 20.0.4.03, and it's all the other information. So it's basically running in Ubuntu, right? It's not Docker related. I just wanted to make sure. Yeah. So this is the second command. Cool. We're doing great so far. I hope no one is. What's the difference between Ubuntu operating system and Ubuntu container other than the absence of kernel? Other than the absence of kernel, there is no GUI. So it's just a. If you say that only the bash terminal is there, there is no desktop environment. What else? The size is a big difference. There are many other graphic drivers that are not needed because you don't have the GUI. So I think these are the the difference that will be there, right? Yeah, exactly. This is Ubuntu server, right? Obviously, yeah. Uh, Great. I'm really happy that a lot of you people are actually being able to follow. So right now, okay, this is fine. But let's say you want to, do some experiments and stuff, right? You want to have, you want to run some bunch of command. You want to get the bash shell directly. You don't want to every time try out a command through Docker container run. What do we do? So this is a very cool hack, right? So as you might remember, and Obiru just said that a container will be running as long as there is a process running inside it, right? So what if we give it a fake process? And you know what? Can even give an idea of a fake process that will be running for some duration of time. Uh, do you know a command that will be running for some duration of time? Is there any command in your mind that will just run for a certain duration of time? Man will run. Yeah, that's correct. Man will run. Ping will also run for a certain duration of time. But what if you can just simulate the duration? Okay, I'm not going to make this a guessing game. So the command is sleep, right? You're going to sleep and 5, and you'll just run for 5 seconds. So it gives us much better hold of. Yeah, delay also works. Yeah. So let's try to run the sleep command and pass it through Ubuntu. Okay, pass it through this image. So let's do Docker container run Ubuntu sleep 10. Well, we might have screwed up. If you run this command, you might see that your terminal is hijacked. You cannot do anything, and it was hijacked for 10 seconds. The reason is, most of the time, like if you do Docker container run and you run a container, it's going to be running in your foreground. That is, it is going to run in your in the same terminal. Now, if you're in a local machine, you can start off bunch of terminals, right? That's fine. But let's say you're on a server, you're dealing with a server, you have SSH into a server. So you don't SSH twice into the server, right? Instead, Docker gives us another, something like a flag, which will help us to run the same container in the background. So let's try to find what that flag is or the option is. So let's do Docker container run and do help. Whoa, it's a lot of things, but let's move. Sorry, it's in the Docker container help, not Docker container run help. So that's just help. Okay, they gave the same thing. I don't know why it's not showing me this. Docker run help. Okay, Docker run help showed this. Okay. So if you do Docker run help, there is this command called detach, which will run the container in the background and will just print the container ID. So we'll be using that. So if you look, so Docker run is basically a shortened version of Docker container run. Docker is smart enough to know that if you're running something, that means you're running a container itself, because container is the running instance, right? So I will do Docker run. Then in the option, I will specify -d, because it will then run the command in the background. Then I will specify the image, and then I will specify my command, which is sleep for some seconds, right? So let's do that. Docker run, not container run. Docker run -d. Let's go with the Ubuntu. You can try out with different OS image as well. And then let's do for sleep. Let's do it for longer time. Let's say do it for sleep 300. Press enter. It's going to give me the container ID, and it's running in the background. How do I know if it's running? Well, our favorite command, which is docker ps. Let's run that, and you can see it's running on Ubuntu. It's running the command sleep 300. It was created 11 seconds ago and it's up 11 seconds ago and it's currently running. That's why it showed in docker ps, right? So this is the command, and then do docker ps and make sure you're able to see the container that's running. Now My main target was to teach you about this specific command called exec. Let's say now you want to execute some command on a running container. In that case, we use this command called docker exec. So you do docker exec, and then you specify two things. You can specify either the container ID or you can specify the name, whichever is familiar, convenient to you. Let's go with charming Chatterjee, right? So docker exec charming Chatterjee, and I'm going to run ls. Let's try that out. And it ran the command. You can try with different commands as well. So you can do that cat /etc/os release as well, and will give us all the output as well, right? Hope it's working. Yeah. But it's still not what we want. We want a bash. We want a bash shell to our hand. What do we do? Well, you might know that there is this binary in the bin file, which is /bin/bash. We can just execute that and press enter. But nothing happened. Well, again, can anyone guess why nothing happened? I wanted a terminal, but it didn't give me a terminal. It instead just showed me nothing and moved my move my terminal to the next point, move my cursor to the next point. Yeah. Any idea why is this happening? There's a Q&A. I will take that Q&A. Can we SSH into the Ubuntu image container? Yes, you can. Play with Docker is amazing. So press Alt Enter to get out of the the full screen. Click on Add New Instance. It will create another instance for you. Wait for it. Then go to the previous instance and we'll find this, this SSH thing, right? Big thing. Just copy that and go and do Control Shift and V, by the way. Okay, Control Shift and V to paste it. Press Enter. Just do yes, and now you're in the old machine, in the other terminal. So if you do Docker PS over here, I forgot to zoom in. I'm so sorry. We can see the same thing, right? But this is a different. So I basically SSH into the same machine. I hope that answered your question. Bash operand and closed. Exactly. So a bin/bash, should I be using this file? Yeah, let me just use this. I will just stop the instance. Let's not use their memory. So yeah, let's get back over here. Alt Enter. I hope Docker PS is still running. Okay, it's still running. It's 3 minutes. I have 2 minutes left. So exactly. So bin/bash is expecting you to give a input which you're not giving. So there's another mode which is called the interactive mode. So if you go back to this command, pass this thing called -i and press enter. Now you're going to, you might think like this command has hijacked a terminal, but it is not. You can now specify command and it's going to give the output. And this is going to be exactly similar as running an Ubuntu machine and trying out different commands. If you want to do all the evil commands that you shouldn't run, and you want to try out what would happen if you run this command, you can run it in a container and it's not going to harm your host machine at all. So this is just like a normal operating a bash terminal. You can do cat os release. It's not going to take auto completion, unfortunately, but this is like a full-blown terminal you have at your hand. You can get out of this doing Control C, and you will be back to your own host machine terminal. Please edit the bash RC. Later on, I think. Just skip it. So so far it's good. So we explored the Docker exec command. So the command structure is this. If we can SSH into different containers, so each container have different IPs, or the SSH is running different port of the host operating system. So you can, in this case, with play with Docker, they are having different IP. You can see the different IPs in the in the prompt. In other case, I think it was 192.168.0.27. So that's why you're able to SSH into that. Yeah, it is basic. Like again, what I SSH into the same terminal, not I didn't SSH into the Docker container, by the way. don't get confused, Kiran, right? So I SSH, I think I dealt with two things at the same time. So what Obirup asked was if we can SSH into that same terminal, this play with lab, that play with Docker thing from a different terminal. I showed that. And with the Docker container, I showed how to get a terminal. That's not SSH. That's just running the terminal instance. Is it clear, Kiran? Yeah, you said right. Okay. So is everyone with me so far till the Docker exec? Because after this, we will be moving on to our last section, which is Dockerizing the Express application, and we will be done for today. So I hope everyone is clear. Just six, there are like 28 people. So I'll just wait for a few more minutes. By the way, container ID, do not include the angle brackets. It's just a placeholder that I said. You can either put the container ID or you can put the name of the charming Chatterjee or whatever the name is. Okay, thumbs up is here. Which server operating system is our default terminal running in? Well, I just showed you. Do cat/etc/os release. You will see it's running Linux. It's running the Alpine version of Linux. Okay, Neeraj. If you want me to paste the command, okay, I can copy command /os. Okay. So yeah, a lot of. So let's move on to the most interesting part, which is also I didn't show one thing. Oh my god, I forgot. It's my Docker still running. Of course, it's not running. So there is another command called docker stop, and if you do docker stop and then specify the container name or the container ID, it's going to stop the Docker. Okay, it's simple. We'll try it with the next, the next part when we Dockerize. So up till now, we were using certain images that are already there in the Docker Hub. But if you're having your own application, you want to have your own image, right? So let's create a new image. And to create a new image, what file do we need? It was there in the slides. Can anyone guess? Just put it in the chat. Let's see. If you remember the file that we need to build an image from that. What was the file named? No one remember? There were three important components of Docker, right? Docker containers, Docker image, and then Docker. Okay, if you don't remember, it's Docker file, right? I think it's evident from the name itself. So we will need to have a Docker file, and that Docker file will be able to build an image using that Docker file with just one command, right? So, but before getting into the Docker file, we need to have the source code. So what I will do is, I think last session, if you remember, we created an application called the sample express server. So just run this command, get clone, and we will be cloning that same application. Okay, we will just use the API that Rahul created, and we'll try to Dockerize that application. Okay, so after you git clone, do cd and go inside the sample express server. Do an ls. You should see this file. Let me know if you're done at this point, right? Just do a git clone. I think git is installed in the terminal because it ran in my case. So I hope, yeah, it's working. So then what we will do is we will create a Docker file. So to create a Docker file, just do touch. Then with a capital D, remember this, the case matters. So do dockerfile, touch Docker file, press enter, do an ls. You will see a Docker file just created. Okay? And then we will be editing the Docker file. Now, here comes the thing. So unfortunately, only Vim is installed in this terminal. So I will be using Vim. You can either follow with me in Vim, or I will just give you one command. If you run that command, it will automatically fill the Docker file. So if you want, you can just follow with me right now, and we'll be writing using Vim to edit the Docker file. So just do Vim, then just do Docker file, press enter. You'll see something like this. Whoa, it's totally messed up because of my zoom. I have to zoom out a little bit. Just give me a moment. Let's do Vim Docker file. Hopefully you're not facing the issue, but in my case, yeah, now it's fine. It's still not fine. I have to zoom out a little bit more. Vim Docker file. Is it fine now? Yeah, now it's fine. So do Vim Docker file, and why don't we use the editor? Yeah, you can use the editor. I think there's an editor in the web UI. There is. I'm not sure. Wait, let me see. Whoa. Okay. Amazing. Nice. So, uh, okay. I'm not sure if you are seeing this screen. Oh, okay. I have to. Okay, you guys use the editor. I'm going to use the other thing. Just a second. Why can't I do this? Yeah. So, my God, it's messed up. So, yeah, you use the editor, and I'll be using the Vim because I'm sharing this one screen only. So everyone ready with the editor, and then so first we will do is, if you're using Vim with me, the first is in command mode. So press I. You will see insert at the bottom left. That means it's insert mode. Now you can write stuff. So the first thing we will write is from. Now, what is this command? So the first thing that we specify is a base image. Again, so you want to have, before Dockerizing an application, you need to have a base image, right? So in which environment it's going to run. You can specify anything. Like this is a node application. So we have to choose that image, that base image, which supports node. You know, something like Ubuntu or Fedora or something, anything like that. So we can specify from and then the image we are using. Ubuntu over here. But if I do from Ubuntu, the issue is going to be is that I have to again install node. I have to install npm or yarn. I have to configure them and all those stuff. So the thing is, since Docker has a large community, there is already a node image existing. We can use that directly. And how do I know that? You can actually search for Docker Hub node, and you will find that node image over there. So instead of using Ubuntu, we will use the node image directly, and you put a colon and then specify which which version or which kind of like distribution you would like to use. We will use the Alpine version because that's the lightest version, okay? And most of the cases you will be using this Alpine version only because that's very lightweight. And if it's lightweight, it makes it more portable, and all smaller the size, much helpful, much efficient it becomes, right? So the first line is going to be from node colon Alpine. Remember, case matters. So from should be in all be in all caps, by the way, right? After that's done, we'll go to the next line. Now, imagine, like, visualize the container. So now we're in the local machine. Now we have a container that's running node Alpine. What else do we need to have? We need to transfer the source code from our local terminal machine, the local machine, inside the container. For that, what we will do is we'll just copy. So just specify copy, again, all in caps. Copy what? Basically the source, which is going to be dot, which represents whatever is inside my current directory. And I'm going to copy that in my /app folder. Okay, you can name it anything. Standard is to use /app. This is it. So this is the second line. So what this line is going to do, it's going to copy the source code from my machine to the containers /app. Now, after this, if you run commands and everything, you have to specify that /app and every time I have to specify slash app, the best way is to set my slash app as my working directory. So that in future, whatever command we run will be running in automatically in the slash app, right? So third command would be work directory slash app. What it will do, it will set slash app, that location, as my working directory. So that in future, whatever command is we are going to run is going to run in this particular location. Then, if you have a little bit of idea with Node or Node applications, once we get the source code, the first thing we do is npm install, right, to install all the Node modules. So we'll do the same over here. We'll run, and the command is specifically the command that is npm install. So far, we have created a container from Node Alpine. We have copied the source code. We have set slash app as a working directory, and we have run npm install to install all my packages, all my applications, all the requirements. If you're doing a Python project, you would do pip -r requirements.txt. Okay, basically just run the command to install all the package and all the dependencies. Finally, we're going to specify that one command that will run every time your container starts up. Remember the hello world image we had? It had this command called /hello. So every time you run a container with that hello world image, it will print that message. Similarly, every time you run a container with this customized image, what should it run? It should start my server. And for this particular application, the command was npm start. So we'll specify that as well. And this is specified using the command cmd keyword. So you do cmd keyword, then you put an array. In the array, it will be strings, an array of string, and just specify just break the command into with spaces. So the first one will be npm, comma, and put it in. Then you put start, and then close it. So it should look something like this. This is it. This is the Docker file. It kind of like is a recipe. Like first take this image, then copy this source code, set this as working directory, run this command, and then every time the container runs, run this particular command. This is the recipe, and this is all we have to do to create our own Docker image. If you're on Vim, again, to save, press escape to move back to command mode, press colon, then WQ, press enter, and that will save it. So you can do cat Docker file finally, and it should show something like this. If you messed up, I have a hack for you. Just okay, I'm coming into the question of Avirups and Viraj. Okay, so just run this command. Just copy it and run this command. It's going to edit your file directly. So you can just copy it and do Control Shift and V to paste it. Press enter, and then just check Docker file. Nothing, I've just kept all the line as one single line in echo, and then I've just piped it to Docker file. That's what I've done. Coming to the doubt which Neeraj and Ovirup posted. So like the question is why we have run and then we have command. So you can specify npm install as the in the command as well, but the procedure is that the idea is to have all the dependencies, keep all the dependencies that's needed inside the npm inside the run command, and then put the command, this one command that's needed to start the container. So if you make your container persistent, in that case, if you stop the container and run it again, it will just run npm start. It will not run the other commands, the previous commands. Okay, npm run install. Now, making container persistence is a different topic. It's a little bit advanced. I'm not going into that. For the time being, you can keep in mind that the standard practice is to, when it comes to set, you want to set some environment variable. You can say run export. This is equal to this one. Or there's much better way to set environment variable. But if there are some commands that you want to run before you start the actual process, you should specify that in run, and then the actual process should be specified in the command section. Is that clear? I hope that answers your question to some extent. How do I close Vim? Very good question. It's an excellent question. And if you want to save and close Vim, do so. Let me just open Vim once again. So Docker file, you're probably you're in insert mode. Just to escape. I hope I didn't miss anything. So just press escape and then press W and Q, and then press enter. W stands for save and Q stands for quit. If you just want to quit, just press escape Q. Were you able to quit, Orgodip? Amazing. Cheers to you. Yes, exactly. Thumbs up if you're here with us. Because now we're going to move on to creating the image. So I'll just leave it up upon you guys. Can you find the command that's needed to build the image from the Docker file? Just do help and see if you can find that specific command. And PS, I've already given the answer. What's the command, actual command? Anyone? Just do Docker image. That's just help. Just scan. I think you will find something that's related to, building an image from the Docker file. Okay, so just do Docker image. That's just help. And the very first command, build. Build an image from Docker file. So we'll be using that. If you don't know how do we pass arguments to build, don't worry. Just do Docker image build. That's just help. And it will say everything. So we need Docker image build. Then there are certain options that we need to pass, and then the path, right? So this is the command. Yeah, you got it. Docker image build. Cheers, Neeraj, Avirup, Pranab, and Jatin. So we'll be using this, right? So let's write our Docker image build. And there's another option that we will use, which is tag. So we will just tag our image. Otherwise, it will just give a random image name, and we don't want that. So let's do Docker image build. Sorry, it's build -t, and then express app, which is going to be the tag, and then it says we have to specify the path. Now, where is the Docker file? The Docker file is in the exact same directory we are in, right? So place a dot. Okay. Remember this is not a period or anything like that. It's a dot. So it's going to be Docker image build -t, express app, then a dot. So this is going to be it. You can actually ignore the Docker image build because Docker is smart enough to know that if you're building, it's obviously you're building an image. Again, if you're copying the command, make sure you copy the dot as well. Okay, it's not a period, it's actually dot, and it represents that the Docker file is there in my in the current directory. If the Docker file is in a different directory, you can use the -f tag, right? There was this one -f tag. -f tag for file. Name of the Docker file, default is path/Docker file. So something happened. Let's look into it, what happened. So the first thing was, it says sending the build context to Docker daemon. As we all know that there is a Docker container engine that's running at the bottom. So this Docker command actually passed all these arguments to the Docker engine. Then it says node Alpine. The node image was not there in our machine. We only had Ubuntu and Hello World. So it's pulling the node again from Docker Hub. It's pulling the latest version. And you can see it's pulling different layers. Here you can actually see the different layers. Why? Because node in itself is a customized image. So it's built on top of some other parent images, right? So that's the idea. And that's why it is pulling in layers. There's an advantage of this layer by layer approach. If you go into depth inside Docker, you will understand that having this layer by layer approach makes it much easier to do version updates. So let's say you make a small tweak and that's in the topmost layer. In that case, when you pull that, it's only going to update the topmost layer and it's going to reuse the other layers. That's the main idea. I would highly urge you to research on that later after this session. So then it should be downloaded newer image for node Alpine. That was the first step, which is from node:\Alpine. Second step was to copy the directory, which is did. Third step was to set the working directory, which it did. So then it did npm run install, and then this is a bunch of the uh, warning that you see in npm run install whenever every time you do. So just ignore that. And then it has set the command to npm start. Now, if you do docker images, whoa, what's docker images? Okay, I should slow down. Docker images. You should see that there is an Express app which we just built, and the size of that application is 180 MB, and that's all it's needed to run this application anywhere from in any machine which has Docker installed. So let's try to inspect this image and see once more. Docker image inspect. Pass the Express app name. Press enter. You can see by default it took latest, right? You will see a bunch of more information. This is the ID, the latest. Here you can see a parent. In case of Ubuntu, it wasn't there because Ubuntu is kind of like a bare metal layer. It doesn't need to have any other parent. But in this case, it has a parent, and the parent will basically be pointing to Alpine because we used Node Alpine, right? This is the host name and everything. Moving on to this config, you can see it has all the configuration set up. This is the advantage of using a Node image. It has Node version, it has yarn. And over here, you can see the command. Oh, in this case, you cannot see the actual command of npm run install because it is already done. It is already there in the application. But every time you're going to start the container, it's going to have this npm start, right? You could have kept it in here also, like npm install and npm start, but it's going to do npm install every time you start a container, and that's not very efficient, right? So yes, exactly, that will happen. Yeah, it reused the old layer, so it will just pull a couple of other layers, not all the layers. Exactly, Obiru. So, and there you can see all the layers. Each layer has this own SHA, and which is a unique identifier and everything. So we are almost done. So we have an image, we have a custom image. Now what? Now let's start the Express server, right? So what's the command? Docker run. But there is a little small catch, and the catch is up till now, whatever container that we ran didn't need any port, right? But when you use any web development frameworks like React or Express or anything, you would be having it will show that application running on localhost 5000, something like that, right? What do we have to do is we have to open up, we have to expose our host port to the port of the container. Basically, you can imagine like if the container is like a box, you want to create a hole in the box so that you can get information from the container to the host machine, right? So let's, I'm going to show it to you and you will understand much better. So the command will be, sorry, docker run. Then for the port, we specify -p. Then the port is going to work this way. So the first port, colon, so the host port, colon, container port, right? So if I do 5001, colon 5000, it means in the container, the application will run in port 5000. So if you remember in the last session, in the code base, we specified the port that the Express server will run on port 5000. You can take a look at the source code. But yeah, it's going to run at port 5000. And I want that particular port of the container to be exposed to my host's port 5001. You can also use port 5000 over here as well. But I just want to keep it different so that we understand we are able to differentiate between them. So do this, docker run -p. Don't put a space between -p and the other one. At the same time, again, you want to give your container identifiable names. So we will use the name tag, and we will now name it backend API because you will have a lot of containers running, and you cannot distinguish between them by the weird names that Docker suggests, right? So you can specify a name, and then just the image that we're going to use, which is Express app. Do a tab, and this is the command. Press enter. Okay, I think I know where I messed up. It says npm not found. Let me just inspect once again. In PM start, Docker run name backend app express app. Not sure. Docker rm backend. I'm really sorry. Unable to find express app locally. Docker images. Okay, named it wrong. So okay, let's put it express app. Ben.sh. npm is not found. Is it the same in everyone? It's running in your case. Okay. Did I mess up with the Docker file? Let's just, I think, this is super weird. It's not running for me, but it's running for you guys. So I don't think this is the issue. But let's try to deal that. So I have a Docker image. The image is, I'm going to remove the existing Express app. So Docker images rm Express app. Let's enter. It's going to Docker images, not images, is going to be image rm Express app. Unable to reference container is running that using its reference ID. Okay, Docker ps -a. Docker DSC rm. So I have to even remove this container, underlying container. Then I can, I think, remove the Express app. Deleted all that, and let's do a Docker file once more. All right, let's build the Docker Express. It's running npm install. So if it ran npm install, why not? Why will it not run npm start? So maybe it's saying server started in mine. Exactly, Iman. That's what it showed. It should show. Anyways, I hope it will fix this. So let's do. Come on. Oh, okay, awesome. So it actually showed. So it says server started in localhost 5000 in your local machine. Just get out of the full screen mode. You will see this port. Ideally, if you're running it in a local host, I mean in your terminal, you're using Docker in your terminal, you would directly go to localhost 5001, because in your machine you opened up 5001, you mapped 5001 port with 5000, right? So what you can do is click on that, and you will see that I just click on that. It's showing in a different. It will open up in a new terminal, new tab, and you will see the message, "Hello from IIEST." Right? I hope everyone is getting this message. If you're getting this message, just do a thumbs up. Yeah. Woo. It's good that we figured it out. We figured the error out. I missed the double quotes in the npm, but in the inspect command it showed actually npm, but still not sure. I hope people are able to follow up till now. Can we? So there's a question by Upmanyu. Can we see Docker files of images we have pulled? No, I don't think we can. It's a very good question. I never asked this question. Well, I'll get back to you maybe after the session. Can we see it? Because in the image is just a snapshot. It has. I don't think we can, but I'm not sure, so I'll not give anything right now. So yeah, so now you can see this message, and that's exactly the. It's going to be the port. If you have Postman, if you want to test it out, you can go to. I think I don't remember the endpoints. Like it was like to dos slash. If you do a get request, you'll get all the to dos and everything. So this is how we are able to run an Express application in a machine. So now that you have this image, you can run it as many times as you want, and we don't have node installed in the terminal, right? If you do, if you just get out of this machine, you can press Control C, and it will complete. And if you do like node minus D, it's not there probably. Yeah, it's not there. But even then, I was able to run a node application in my machine. So this is the kind of the beauty of Docker and the entire thing. What you can do is, I would suggest you to push this image to Docker Hub. You already have, everyone over here has an account in Docker Hub. Push this image to Docker Hub and ask your friend to pull that and run it, and see if you're able to do that or not. So that's all from today's session, I would say. If we recapitulate what we did, we covered the basics of Docker. When do we use Docker? What are the scenarios when it's very useful? We understood the difference between container and virtual machine. Then we moved on to the three important aspects of Docker: Docker file, Docker container, and Docker image. Do anyone still? Is there anyone who has still doubts about Docker image and Docker container? But I think at this point it's clear, right? So I hope it's clear at this point. And then we did a go through all the basic Docker commands. At this point, I don't think you would need, let's say, when you're working with an open source project, and if you see something like Docker, I would suggest you to use Docker because it's much more easily maintainable. You can easily remove the Docker containers and Docker images. So if you do Docker images, and you can then do Docker image. First, you need to stop all the containers. So you can do Docker stop. So Docker ps minus a, and I think there's actually a quick way to do that, which is if you do Docker ps minus aq, it will give you all the Docker IDs, and you can do Docker stop, then parse it inside that, and press an enter, and it's going to stop all of them. And if you want to remove all of them, you can just do rm. It's going to remove every one of them. So Docker, now you do Docker ps minus a, you will see nothing, even in ps minus a. Okay. So yeah, I would like you to explore now all the various commands and everything. General question: is Docker container similarly encapsulates as virtual machine? If then virus will leak it out of container. Can you show the remove Docker image part again? I'm just going to clear Upman start first. Remove Docker image part again. Okay, I already removed. Okay, I didn't remove images. So if you have Docker images, and you can do Docker image -- help. There is this one command called rm, which says remove one or more images. So now if you look at Docker images, and let's say you want to remove this Express application, right? So you can do Docker image rm, and then you do Express or press tab, it will autocomplete, press enter. It's going to remove all the layers of the image. Is that clear, Upmanyu? So it's I'm going to write the Docker image rm. Is Docker container similarly encapsulated as VM if I run my? Yes, it is. Like so far there is no security leaks, but there are a lot of, if you see a lot of CTF challenges, if you play a lot of CTF, some really hard CTF problems has things related to Docker, where they give you a Docker container and you have to somehow find a backdoor to get out of the Docker container and find the host machine. If the Docker container is well maintained and then there is no open port or anything, it's pretty secure, because at the end the isolation principle remains the same. So yeah. But yeah, if you deliberately put loopholes, then nothing can be done, right? And that actually works for VM as well. If you deliberately put loopholes in the virtual machine, you can still access the host machine resources from the virtual machine. I also prepared a PDF for all the commands that we use today, so you can refer to that. Let me know if you can access this PDF. It will download a PDF for you. It has all the commands that we use today and some further reading materials and a coursework which you can do. And I will just leave the room open for question answers and some feedback, whether you like this session or not, or is there any feedback that you want to give? Um, was the session too boring or it was interesting? Anything? Also, thanks to Abhirup that you started the recording. I totally forgot about the recording. So some feedback or something like anything. Thanks, Neeraj. Um, Also, just let me know if you can download the PDF from that link. I'm not sure if that repo is public. I haven't checked. Awesome. Wow, thanks a lot. Like I also like the way everyone followed the session, and yeah, charming strategy was the funniest part of this. Cool. If there is no more question, I think we'll just stop the session.